In this video, we'll be learning how to apply the distributive property across square roots and how to then simplify those expressions. So let's just jump in and look at an example here. So if we look at this example, we know that the distributive property applies because we have a number out in front of parentheses, and there are two things being subtracted inside of the parentheses. So we know that we can distribute by taking that square root of 5 and multiplying it by each term inside here. We need to be careful as we do this because when we're working with square roots, things become a little bit more complicated. So first things first, I'm going to multiply the square root of 5 times 4. Now, because I am doing multiplication here, I need to really think through what properties apply. And I know that when I multiply square roots, I multiply the numbers that are outside the square root and then the numbers that are inside of the square root. Well, if I look here, there's only one number on the outside, that's 4. And then there's only one number on the inside, and that's 5. So we can't actually multiply either of these numbers together because they're not both outside or both inside the square root. So this just becomes 4 times the square root of 5. And that's as simple as that goes. Then if we look at the next one, first things first is I see this subtraction here. So I know when there's a subtraction there that this is really a 1. And then if I use keep, change, it's really a negative 1. So this is really the square root of 5 times negative 1 times the square root of 20. So in this part, we know that we can multiply any of the numbers that are outside of the root. In this case, I only see one number outside the root, and that's the negative 1. So that's going to go first here. I have negative 1, and then the numbers inside of the root can be multiplied. So here we have the square root of 100. Now, before I finish this problem, what I need to do next is I need to look at each of these and decide if they're fully simplified. Because this problem right here has now changed. It was multiplication that we used to distribute, and now we are adding, or if you view it as subtracting, square roots. And in order to add or subtract square roots, we need to simplify them as much as we can, and then combine any like square root parts. So if I take a look at 4 square roots of 5, I know this is fully simplified because 5 is not divisible by any perfect squares. It's not divisible by 4, it's not divisible by 9, not divisible by 16. So, it's not divisible by any perfect squares other than 1, and everything's divisible by 1. Then if I take a look here at the 100, what I notice is that 100 is a perfect square. So, if I use keep, change there, and then I think about this, the square root of 100 is 10. So this can actually simplify to negative 1 times 10, which then simplifies to be negative 10. So we can actually simplify that part further. Now, if I combine this all together, we have 4 times the square root of 5 plus negative 10. And if I take a look at this, what I notice is that there's no like square root parts. And as a result of that, none of these can be combined together because they have to have like square root parts in order to be combined, just like when we have like terms. Remember, like square roots are very similar to like terms. So this right here, 4 times the square root of 5 plus negative 10 is as simplified as our answer can go. So now let's take a look at something a little bit more complicated. So if you look here, you'll notice that we have 2 sets of parentheses, each with 2 terms inside of them. So this is going to need to use big distribution. We're going to have to take everything in the first parenthesis and multiply it by everything here in the second parenthesis. So this is going to take multiplying and addition of square roots in order to fully simplify. So let's go ahead and give this a start. So here we have 2 square roots of 21 times the square root of 7. So I write this out, 2 square roots of 21 times the square root of 7. So here we're going to need to multiply the numbers on the outside of the square root and then multiply the numbers on the inside of the square root because we are multiplying with square roots. So first I notice here that the only numbers on the outside are 2 and then the implied 1 there. So this would just be 2, and then if I multiply 21 times 7, I get 147. So there's our first multiplication. Then from here, I'm going to take 2 square roots of 21 times negative 3 square roots of 6. So I'm going to use keep change here. So here I have plus 2 square roots of 21 times a negative 3 square roots of 6. So here I multiply the numbers on the outside, which are 2 and negative 3, so that becomes negative 6. And then I multiply the numbers on the inside, so 21 times 6 becomes the square root of 126. Then I take the next set. I take 4 times the square root of 2 times the square root of 7. So 4 square root of 2 times the square root of 7. So multiply the numbers on the outside, which is just 4, times the numbers on the inside, which is 2 times 7, which is 14. And then lastly, we take 4 times the square root of 2 times negative 3 times the square root of 6. So I have plus 4 square root of 2 times negative 3 times the square root of 6. And again, multiply the numbers on the outside, which gives me negative 12, and the numbers on the inside, 2 times 6 gives me a positive 12. So first things first is I use big distribution, multiply all the numbers on the first parenthesis times all the numbers in the second parenthesis. So at this point, I'm going to focus on all 4 of these square roots in this line right here. And my goal now is to get all of these simplified. So because I see addition, 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 I know that I am adding together square roots. And when I add together square roots, I need to get them fully simplified and then look for like square root parts that I can add together. So I'm going to go through one at a time and simplify them one at a time. So if I look at 2 square roots of 147, if I take a look at 147 and start dividing it by the perfect squares, I notice that 147 is divisible by 49. So here I write this as 2 times the square root of 49 times the square root of 3. Then I know the square root of 49 is 7, so I have 2 times 7 times the square root of 3, which becomes 14 square root of 3. So I was able to simplify that first one. Then we take a look at the second one. So we take a look at 126 and start looking at which perfect squares 126 is divisible by. And if I start taking a look at it, 126 doesn't divide by 4, but it does divide by 9. So here I'm going to split this up, and I get negative 6 times the square root of 9 times the square root of 14, because 9 times 14 gives me 126. I then know from here that the square root of 9 is 3, so I have negative 6 times 3 times the square root of 14, which in this case becomes negative 18 times the square root of 14. Now I take a look at this next one, and what I notice is that 14 is not divisible by any perfect squares. It's not divisible by 4 or 9 or 16 or anything larger than that. So this I don't have to do any simplifying on. I just need to add it down here into the mix as is. And then finally here I take a look at negative 12 square root of 12. I know that square root of 12 can be split up into the square root of 4 times the square root of 3. So I'm going to break that up into the perfect square it's divisible by. I know the square root of 4 is 2, so that's negative 12 times 2 times the square root of 3, which becomes negative 24 square roots of 3. So now from here, I need to add together any like square root parts that I see, very much like adding together like terms. So I'm looking for identical square root parts. So here I notice that I have the square root of 3 attached to 14 and negative 24. So I add together those coefficients just like I would with like terms. So I have negative 10 times the square root of 3. And then here, both of these contain the square root of 14, so those are like square root parts as well. So I add together those coefficients. Negative 18 plus 4 is a negative 14 times the square root of 14. And because the square root of 3 and the square root of 14 are different square roots, that is as far as I can go with combining like square roots.